Game Dev Journey. Now what we're going to do is add a script to control the movement of this player. So you select your player node and click on the little scroll with the plus. It's going to add a script. Now for the template, use empty so that we don't get a sort of pre-populated script, and the rest is all fine. We can click create. Now you'll note that because the player is in Area 2D, it extends Area 2D. This means that it can do everything an Area 2D can do. Right. Now we need some variables to control our player. Our player will be able to move at a certain speed that we determine. So we can create a variable for its speed. If we want the speed variable to appear in the inspector, we need to export it. So if we say export, what type of variable is it? It's an integer, so our speed is whole numbers, and its name is speed. That will make it appear over here in the inspector. We have script variables, speed, and we can change this value directly in the inspector now. What else do we need? We need a velocity, and that can be a vector 2. What is a vector? A vector is simply, well, a vector 2 is something that simply has two properties. So velocity may have a speed and a direction. So we're going to take advantage of the fact that it has two properties. And we don't want to allow the player to move beyond the boundaries of the screen. So we're going to find out what the screen size is, or actually we're going to set the screen size ourselves. So we'll say screen size equals vector 2, and we'll say it's 480 by 720, like a cell phone in landscape mode. Now this won't actually change the screen size. That's just us setting the boundaries. To change the actual screen size, we have to go to project settings, window, and here's the screen size. So our width is 480 and our height is 720, and we can close that. You'll immediately see now, if I zoom out, that the screen size is portrait, like a phone now. Those are our new dimensions. If you click script, it'll take you back to our code. Right, so using that export keyword on the speed variable allows us to set its value in the inspector, as well as letting the inspector know what type of data the variable should contain. This can be very handy for values that you want to be able to adjust, just like you adjust a node's built-in properties. So if we click on the speed variable here now, we can type in 350, and this speed variable is now set to 350. Velocity will contain the character's current movement speed and direction, and screen size will be used to set the limits of the player's movement. And later on, the game's main scene will set this variable, but for now we just set it manually. We can actually get the computer to work out the size of the screen for us. So now we want to move the player around. So we're going to use the process function to define what the player will do. The process function is called on every frame, so you'll use it to update elements of your game that you expect to be changing often. You need the player to do three things: check for keyboard input, move in the given direction, and play the appropriate animation. First, you need to check the inputs. For this game, you have 4 directional inputs to check, the 4 arrow keys. Input actions are defined in the project settings under the Input Map tab. In this tab, you can define custom events and assign different keys, mouse actions, or other inputs to them. By default, Godot has events assigned to the keyboard arrows, so you can use them for this project. But if you want to map your own keys, you could go to Project, Settings, Input Map, add an action, move right, move left, move up, move down. So here are all our actions. Now we can map keys to them by clicking plus. We can say physical key, and right can be D. Physical key means that most people use a keyboard with the QWERTY layout, QWERTY, but in other countries they may use keyboards that have a different layout. Using the physical key means no matter what layout the keyboard is using, it will always be that physical key on the keyboard. Move left will be A, move up will be W, and move down will be S. So there we've set up our own key mappings. Close that. You can detect whether an input is pressed by using input.isActionPressed, which returns true if the key is held down and false if it is not. Combining the states of all 4 buttons will give you the resultant direction of movement. For example, if you hold right and down at the same time, the resulting velocity vector will be 1, 1. So in this case, since we're adding a horizontal and a vertical movement together, the player would move faster than if they just moved horizontally. So when they're pressing 2 keys, they're almost getting double the speed. So moving along diagonals is going to make them move almost twice as fast as just moving along horizontals or verticals. So we need to prevent that by normalizing the velocity, which means setting the velocity to 1 in all directions. And then we multiply it by the desired speed. So we can make a function here called getInput, and we can define our velocity variable. So we can say velocity now equals vector 2, and we can say if input dot is action pressed, and here are our move downs and so on, and we're going to say move left. And what are we going to do? We're going to set velocity to minus equals 1. So we'll set velocity to -1, and we'll do the same in the other directions. Input is action pressed, right, velocity equals 1 if input is action this will be up velocity, and I have made a mistake which I'll correct in a second, and input is okay. The mistake I made is I'm set velocity has 2, because it's a vector 2, velocity has 2 components, in this case x and y, and I'm trying to set both of them for all of these. So moving left is the x direction, so this should be velocity dot x. Moving right is the x direction, so velocity dot x. Moving up is the y, so velocity dot y, and moving down is the vertical as well, so it's dot y. So that will now map our actions, moving left, right, up and down, to changing the value of the velocity in the X or Y direction. And then remember, pressing 2 keys at once will make our character go twice as fast in the diagonals, so we want to normalize the diagonals. So we want to say if our character is moving, which means the velocity length will be greater than 0. It means our character is moving. Then we want to make sure that velocity is equal to velocity dot normalized, and multiply that by the speed. And that will make sure that the character moves at the same speed in all directions. So by grouping all of this code together in a get input function, we make it easier to change things later. For example, you could decide to change to an analog joystick or another type of controller. So we could call this function from process and then change the player's position by the resulting velocity. To prevent the player from leaving the screen, we're going to use the clamp function to limit the position to a minimum and maximum value. So let's create the process function, and there it is. Now notice functions that begin with the underscore like that means that they are built-in functions. They already exist and are provided by Godot. Notice our function we made does not start with an underscore. Get input is not a function that comes ready with Godot. We created it. Okay, so we can call our get input method, and we can then update the position of the character on the screen. So we can say position of the player is going to be equal to our velocity times delta, and then we're going to lock or clamp the X and Y positions to the size of the screen. So we're going to say position dot X equals, and this is a built-in function called clamp, and we can say, and there you can see it actually comes up with clamp. We need a value and then a minimum and a maximum. So the value that we want to clamp is the X position, and then the minimum value is 0 and the maximum value is our screen size X. And we're going to do the same for the Y. So we're going to say position.y is equal to clamp. We want to clamp the Y position now to 0 and screen size Y. So the player cannot escape the bounds of the screen. Now we can actually test this. So we can actually run our scene by pressing F6 or clicking on this, and we have our little player there, and he can move around, but he cannot escape the boundary of the screen.